Good afternoon, everyone. Today I'm going to do another volume problem, calculus style, where we find the volume of a solid using cross-section techniques. We're going to cut out like an infinitely thin 2D cross-section, and we're going to integrate over all cross-sections to find the volume. In this particular problem, here we go. The problem states the solid lies between planes perpendicular to the x-axis at x equals -2 and x equals positive radical 2, so negative square root of 2 and positive square root of 2. The cross sections perpendicular to the x-axis, the same cross sections, happen to be circles whose diameters run from the parabola y equals x squared to the other parabola y equals 4 minus x squared. So my handwriting, I tried to keep it legible here. Now, so in other words, what we've got is we've got a solid. Basically, it's kind of sort of like a football, but don't read too deeply into that. It's kind of sort of like a football. It's got sharp tips at negative square root of 2 and positive square root of 2. It's sort of kind of like a football. And that's what I was just saying here. Our solid looks kind of sort of like a football with the sharp tips that have an x coordinates of plus or minus radical 2. So there's that. Now, my attempt to draw it above was not the best. It should be symmetric. It looks a little fatter over here than it does over here, and that's just the imperfections in my drawing, and I'm sorry about that. So there's that. And I was just commenting on my attempt to draw it. It should be symmetric about the horizontal line passing through the two sharp points, or about the vertical line cutting through the center. Either one of those. Okay, now it's time for the math. Now here's just the 2D. Here's y equals x squared right here, the parabola x squared, and here's 4 minus x squared. Let me zoom out so this isn't so muddy. Okay, so here's x squared, and here's 4 minus x squared. And I kind of messed up when I tried to draw it, so ignore this little strip right here. Here's the parabola. Let me try to get it in sight here. There we go. There it is. And there's the region. I've shaded it in sort of striped shades there. Again, it has a sort of a football look to it, kind of. And again, here is your negative radical 2, right here at this sharp place. And here's your positive radical 2. I ran out of room to label it almost. Now, these circles are the diameter of these circles is going to be 4 minus x squared minus another x squared, because the height of these circles is going to, or should I say the diameter of these circles is the highest point. Well, highest, when I say highest, I should be careful. It's highest relative to the y-axis. So 4 minus x squared, and lowest minus the lowest relative to the y-axis, which is just ordinary x squared. Now, cross-section circle diameter equals highest in y minus lowest in y. We're talking about the y direction, not the z there. I probably should have clarified that. So high minus low. And so the circle area is a sub x, which is pi r squared for a circle. But that's pi d squared over 4. Okay, and so now, here's the deal. Now, our diameter d, let me go back up, is 4 minus x squared minus x squared. That's 4 minus 2x squared, and you can factor out a 2, and you get 2 parens, 2 minus 2x squared. So we've got, we wind up with pi times diameter, which is this whole thing in braces. squared, 2 and the parens and all that squared over 4. Pi d squared over 4 is what I'm doing. And but lo and behold, you can take this 2, you take the 2 out, you got to square it, but you can take it out as a 4, and it cancels this 4 down here. And you just get pi and 2 minus x squared squared. That's a 2 there. And this is the number 2. And then you do FOIL, you square it out, and you'll get pi and x to the 4th minus 4x squared plus 4. So finally, that's our area, our ace of x. We had to do a little digging there. Now, hence, our volume by definition is the integral. That's kind of blurry. Why is that so blurry? A to b. That's a letter A there. Little a to little b of capital ace of x d of x. So the volume is a to b of ace of x d of x. Now our little a is negative radical 2, our little b is positive radical 2, and our area is pi times this guy. Our whole a of x is just pi times this guy. From what we saw a minute ago, dx, and we're integrating over dx from negative radical 2 to positive radical 2. And you'll go through the motions, you'll go through some calculus, you'll get you integrate x to the 4th, you get x to the 5th over 5, you integrate x squared, 4x squared, you get 4/3 x cubed, and you got a minus sign there accompanying it. And then 4x, and you just go through all that. Now notice that these are all odd exponents, x to the 5th, x cubed, and x to the 1. And so you can just you can put a 2 out here, and instead of going from neg rad 2 to rad 2, you can just go from 0 to rad 2, because you've doubled this out here. And you're just, this is true because you're subtracting negatives, but you get this. Now we know in this particular situation, you can't always wish 0 away, but in this problem, we can wish it away. 0 is truly gone because all these vanish. And we can just look at the upper limit. You plug radical 2 in there, you'll get these numbers. You'll get a common denominator, and then you'll finally get 32 in there, rad 2 over 15, and then multiply through by twice pi, and you'll get 64 rad 2 over 15, and that's your final answer. We are truly done, and that is our volume. We had to do a little digging, but we finally got it, and I hope this helps. And let me just reiterate before I close that the circles were YZ circles, like in the football. That, let me see if I can't find that football, well, it's not maybe exactly a football, but in our pseudo football, these cross sections are YZ. They're perpendicular to the x-axis. I probably should have pointed that out earlier. These are YZ circles, and our sharp tips are at neg rad 2 and pos rad 2. It's a football-like object. It's I'm not saying it has everything like a football about it, but it's semi like a football. But anyway, thank you so much.